hello everyone, and welcome to today's masterclass, Railway Asset Management with BIM and GIS. In this session, we will explore how BIM and GIS can transform railway asset management. We will see how these technologies can help extend the life of assets, optimize maintenance, and improve long-term efficiency through a life cycle-driven approach to digital models. My name is Thaisa Figueroa. I'm institutional manager and program owner here at Ziggurat, and it's my pleasure to be with you today. And if you are new to Ziggurat, let me briefly introduce us. We are an online educational institution with over 20 years of experience in e-learning. We offer master's and postgraduate programs in architecture, engineering, and tech management, helping professionals around the world advancing in their careers, and we are incredibly proud of our diverse and dynamic community with more than 20,000 students from over 120 countries. But before we dive into today's session, let's make it interactive. We'd love to hear from you, so please share with us in the chat where are you joining us from today. Let's keep the energy high and stay connected through this session. Okay, so please interact with us and send us on the chat where are you join us today. And today's masterclass is closely connected to our Masters in Global BIM Management, Civil Engineering, and GIS, which prepares professionals to work in international collaboration, focus on real civil engineering projects, and the balance between three key pillars: technology, process, and people. And now I'm happy to introduce Manuela Barbeiro, International Admission Teams Manager at Ziggurat, who will share why this program can make a real difference in your professional journey. So Manuela, it's over to you and thank you.
So good afternoon, good evening, everyone. So as Thaisa say, I'm International Admission Consultant in Ziggurat, manager. And today we're talking about the Master in Global BIM Management, Civil Engineering and GIS. These programs goes behind a traditional BIM master. So it's a career accelerator designed for professionals ready to lead in digital construction. Through a practical project-based approach, you'll gain a deeper expertise in the tool and the methods to drive the entire, in this case, infrastructure life cycle. So delivery fully online, with flexible scheduling. It's the perfectly tailored for professionals looking to advance international without opposing their career. If you can go to the next slide, please. So when now we check a little bit more, so the benefit in joining a master in Ziggurat. So when we talk about digital transformation in construction infrastructure, Ziggurat stands out as a global leader. Our master program in BIM isn't just recognized, it's ranked among the best for a reason. So we don't teach you BIM in isolation. We combine it with civil engineering and GIS, giving you the skill to manage infrastructure, urban planning, and asset management at a whole new level. You will be working with cutting-edge tools like Civil 3D, Revit, Infraworks, and R2GIS, so exactly what the industry is using today. And this is just theory. Just work on real case studies, face real challenges, and build the confidence to apply BIM in practical, impactful way. So if you're looking for the program to prepare the future, this is it. Can you go to the next one, please? At Ziggurat, learning mirrors the reality of your future profession. You will work in simulated project, present your idea to mentors who act as real clients, and train with the same tool that leading companies have today. So we combine with you award-winning methodology, the dynamic Canva platform. The program becomes more than education. It becomes a true career accelerator. What truly sets the program apart is the personalized support you receive. You're never just a number for us. You are a benefit from dedicated guidance and continue follow-up to ensure your success from start to finish. At the same time, our flexible online format give you the freedom to learn from anywhere in the world while remaining part of the vibrant global community of BIM professionals. And behind the classroom, there is a launch pad for your career. So with the national recognized certification and direct connection, top firm in the sector, you are positioning yourself for growth and global opportunities. We talk about now in the next slide about the career opportunity. I want to take a moment to talk about something that many of you are probably thinking around is what kind of career I can actually build in BIM. Today, BIM is much more than just a tool. It's a gateway to new high-impact career in the construction and designer industries. We are seen as growing demand for professional, why not only understand BIM tools, okay? So in the who can lead digital transformation within their organization. Okay, at Zigora, our master is built to prepare you for exactly that. You'll gain the skill, experiences, and international recognition to step into roles that are shaping the future of the construction industry. So if you are ready to take this next step, this is the real and good moment. So thank you very much to everyone.
Thank you, Manuela. Thank you so much. And now it's my pleasure to introduce our esteemed speaker for today's session, Mostafa ElAshmawy. Sorry if I'm not saying well, Mostafa, please. He is Principal Implementation Consultant at Autodesk, Professor at Ziggurat, Digital Twin and Open Standards Advocate, and also recognized among the top LinkedIn creators in Australia. He is the second in high tech and hardware, and the ninth in technology and innovation. I saw this today on LinkedIn. It's a big news. And a quick reminder to our audience, if you have any questions during the session, please drop them on the chat, in the chat, and we will address them during the Q&A at the end, okay? Mostafa, thank you so much. Welcome. It's a pleasure to have you here with us today, and the stage is all yours now. Thank you.
Thanks a lot. Thanks, Stephen, and thanks, Manuel, for this introduction about Ziggurat Masters. And hello, everyone. Thanks for joining today's session on Railway Asset Management with BIM and GIS. Just to confirm, everyone can see my screen?
Yes.
Okay, perfect. Okay, so yeah, I'm Mostafa ElAshmawy. I'm a BIM and digital delivery consultant. Currently, I'm working mainly with Autodesk as principal implementation consultant, and also I'm a professor at Ziggurat Institute. However, just for your information, in this session, I'm not representing Autodesk. This session is based on my knowledge, experience, and I wanted to transfer that to you based on my previous works on the rail industry. As part of my career, I worked for around 6 or 7 years in the rails industry in one of the largest infrastructure projects in the Middle East, which is Riyadh Metro project. And I learned a lot during that my work in that project, and happy to be talking today about this topic. In this session, we mainly aim to cover the use of BIM and GIS, not only for design and construction phases, but to understand that BIM and GIS has a deeper use when it comes to the entire asset life cycle. And I'll go through roughly 4 main sections. So firstly, we will aim to understand the importance of efficient railway asset management. Railways are massive long-term investments, and the way we manage them directly affect performance, safety, sustainability, and cost efficiency. Secondly, we will explore the key components of railroad operations and management. This includes main items that usually we focus on, like rolling stock, track infrastructure, communication systems, and also the safety protocols. Then we will discuss the role of BIM and GIS that can play a powerful role in enhancing railroad asset management by helping in visualizing assets, making smarter decisions, and keep everything coordinated over time. Finally, we will discuss the asset information requirements and within the context of rail projects, how usually owners and operators will communicate their information requirements to their supply chain to ensure they capture the required information at handover stage. So by the end of the session, we will walk away with some understanding on how we might leverage BIM and GIS, not just for the delivery part of the project, design and construction, but also for the asset management part of the project. I'll try to speak for around half an hour, not more, to allow some time for Q&A. But yeah, sometimes I forget myself and keep speaking, so I'll try to limit myself to the time this time. But feel free to drop your questions in the chat bar as I go, and I'll pick it up at the end of the session. So firstly, to tackle this topic, we should briefly go through the importance of efficient railway asset management. Usually, most of the students that attend our masters in global BIM management and go through the railway modules, we have two main modules, one related to design and one related to the asset management. But usually the students are from design or construction background. Most of the time they don't have the experience in the facility management or for the asset management. So it's always good to understand the significance of efficient railroad management. And the concept of efficient railroad management can't be understated in our present day, where we have complex transportation landscape. Railroads have historically served as the backbone for vast regions, helping the economic growth and facilitating global connectivity. And these extensive networks of steel have seen goods, ideas, cultures, helping in moving all of that through miles and miles and kilometers, in reaching societies in countless ways. And as the technology advances, integrating BIM and GIS has emerged as an instrument for better management of these assets. One of the aspects where efficient railway management is important is the safe operation. Safety and reliability stands as the twin pillars underpinning any successful railroad operation. And these are not just metrics or KPIs, they signify trust. Every time a passenger boards a train or a business ships goods, they place implicit trust in the system. And BIM and GIS have emerged as game changers in design and construction, and they have the potential to enhance this safer operation using detailed digital representation of the assets that can be accessed through BIM, offers level of granularity previously can't be imagined. Paired with the real-time geospatial data from GIS, the potential hazards can be proactively identified and then neutralized. So another point where efficient railway management is important is whenever we have an efficient asset management for railway project, we can optimize the infrastructure and also reduce the downtime. And this is another important aspect where infrastructure forms the skeletal framework of the railway system. And efficiently managing this framework means ensuring that we are taking the maximum benefit out of it. In many of our urban environments, space is at a premium. and usually finding the good location for expansions of railway is something hard because usually this is done on city scale, and we want to ensure that we have the optimum bus. So optimizing the infrastructure and ensuring that we are selecting the correct locations to help the society and the communities. That's where BIM and GIS can also provide this eye view of existing layouts and guiding the precise enhancements without need for unneeded expansions. So it will be focused based on the actual need of cities. Another challenge facing railroads is the environmental aspect, and in an era marked by the environmental consciousness, railroad are more relevant than ever as one of the most eco-friendly modes of mass transportation, and railroad have significant role in fight against climate change. So efficient railway management helped by GIS or BIM can directly translate to optimized energy use, waste reduction, and more environmentally conscious route planning. Another concept is harnessing the big data in railway. In the age we live, it's often referred as the age of data. Railways with their huge networks and countless variables are data gold mines. And harnessing this data effectively, however, requires specialized tools. BIM and GIS offers both the three-dimensional snapshot of the asset and also the geospatial intelligence that can also host all kind of information to support the better management of this big data. Another point is ensuring the seamless transportation network. As the world becomes interconnected, the role of railway in facilitating global trade and logistics has evolved, and efficient rail management is not only about better management of trains, it's about ensuring that we have seamless intermodal transportation network. So usually we will not design a railway network on its own. We need to ensure that it's connected, for example, with bus stations, connected with airports, connected to other means of transportations that can help in better connection and better service for the end user. So it's never about just managing the railway alone. Usually these networks are managed within the context of larger public transportation. The long-term vision for efficient railway management, it's vital to understand that it's not just a destination, but it's a journey. And this journey marked by constant evolution and innovation and commitment to excellence. So there is a huge potential for BIM and GIS to keep serving and keep evolving to help the evolving railway management, because railways is an essential component from any future transportation network in any city. So there is always a growing potential for more use cases where BIM and GIS can support the railway management. In the next part, we will speak briefly about the usual railroad operation and management, and focusing mainly on the main components of these railway operations. And in principle, the railway operations and management, it's in heart about ensuring the safe, efficient, and reliable movement of goods and passengers across a rail network. And mainly, there are many components involved in that, but some of them are more critical. And first component is what we call the rolling stock. The term rolling stock in the rail transport industry refers to railway vehicles, including both powered and unpowered vehicles, So locomotives, freight and passenger cars, any kind of railway cars like that you see here that's um, um, taking either passengers or goods, moving them across cities or countries. And it can be classified into two main types. We have the locomotives that are the engines that provide motive power for trains, and also we have the rail cars, which are the vehicles that carry cargo or passengers, and it comes in various types. Another important component, which I think more relevant to us as BIM and GIS experts, is the infrastructure. So the track infrastructure, which can mainly include the railway tracks, which is a physical infrastructure for railroad consisting of rails, sleepers, ballast. Proper track maintenance is vital for these components to ensure the train operation is at its peak, to enhance the safety, to minimize wear and tear. And also we have the infrastructure that would carry these railway tracks. We have bridges and tunnels, where rail network often include bridges and tunnels to traverse natural obstacles like rivers and mountains. So these are usually, so it's rare to find a rail network without bridges and tunnels. And for sure, there are the stations and depots or any other buildings that's supporting this infrastructure and supporting the railway. Another component is the signaling systems, which is usually the traffic control signals and communication systems. Those signaling systems mainly dictate the movement of trains, and the communication systems connect the modern railways through connecting the railways with control centers and ensuring that the train movements are coordinated. These systems enable the real-time tracking to ensure that correct decisions are taken on time. Another component which is not physical but very important when it comes to railroad operation and management is the safety aspect. One railway accident can cause lots of waste in lives of the passengers, and also loss of money, loss of resources would be wasted. So whenever we are managing such complex projects, it's essential to understand that the safety is a critical component, and there are usually safety standards to manage this, where usually the railway management should adhere to these safety standards, and always there are emergency response plans where railroads should comply to it whenever there is an issue or an emergency case. Then, where can be the role of BIM and GIS to enhance railroad management? And there are two aspects of this before going into the details. Sometimes we look into that from the perspective of the delivery teams. And when I'm speaking about delivery teams, I'm speaking about pre-handover stage. So anything during design and construction of railways, I refer to this as the delivery teams of a railway project. So there is the perspective of these guys that can understand where BIM and GIS can support the railway asset management, and also from the other side, the facility management teams that can search for uses for BIM and GIS where it can help the post-handover stage. Because usually there is huge investments that's done during recent years where BIM and GIS are developed during the design and construction phases. So it would be disappointing if we just take all of these digital models and just throw it or just hand it over as static data and put aside. So it's always recommended to make longer use of this data post handover. One of the main aspects where BIM and GIS can enhance the railroad management. Firstly, for the GIS, where GIS can help in capturing the spatial data. And GIS can capture any type of data related to the infrastructure or the city scale information. So you can have street data, building data, vegetation, and integrate all of this into GIS database, where usually railway projects are on large areas, because sometimes it's whether it's inside one city or whether it's connecting two cities or across countries. Usually it runs on a huge scale, which can't be digested in BIM models only. So usually GIS can help in understanding and digesting this geospatial context. Data integration and visualization is another aspect where BIM and GIS are superior in that aspect. So firstly, the fact that BIM and GIS integration is something that can be achieved. So these systems on its own can be integrated. So the BIM can help in capturing the infrastructure or the buildings, and then GIS can support the spatial aspect of it. And then there is also the integration of real-time data. GIS and BIM in principle are information management systems, and they can collect real-time data from various sources such as track sensors, weather stations, train positioning systems. So any types of data can be fed into GIS and BIM. And when I'm speaking about BIM here, I'm not only talking about BIM models, I'm also speaking about BIM from its larger context. I'm talking about common data environments. I'm talking about information management systems that can not only host the BIM models with its metadata, but also additional data that can be linked to the BIM models on a larger context. Another concept is the asset lifecycle management, where BIM and GIS can help in maintenance planning. We have success stories for BIM and GIS supporting scheduling and planning, what's known as 4D. So this is also usable for the maintenance planning and for expansion planning for networks. So usually predictive maintenance models can be built based on historical data and real-time condition monitoring, and then some simulations can be done to help in maintenance planning. Another point is life cycle cost analysis. BIM and GIS can facilitate the life cycle cost analysis, enabling railway operators to make informed decisions, because the BIM and GIS tools, and mainly BIM for this aspect, have good tools that can support the cost analysis, the estimation, and takeoffs. All of these tools that's already available in BIM and GIS are helpful when it comes to the lifecycle cost analysis. Safety and risk assessments through simulations and analysis. BIM and GIS integration help safety assessments. So imagine that you have maps in GIS, and you are planning for your route, and now you know that there are areas that can be more suitable than other areas. So analyzing this and having simulations directly on these tools can help in the planning for safety and risk assessments, and also environmental impact assessment. So we can easily, using GIS, understand the factors like noise pollution, air quality, any location of wildlife that need protection, and we can understand quickly the impact of our network on these habitats or these existing buildings. So we can understand the environmental impact of our networks using GIS. Planning and expansion, where BIM and GIS can help in the route optimization. So usually part of the management of railway is planning for expansions. So usually we have existing networks and we are planning for another network or to serve an additional part of the city. Route optimization is an aspect where GIS tools can help in this point, and it considers factors like terrain, population density, environmental sensitivity to identify the most efficient and suitable rail alignments. Also, infrastructure design, where BIM is used in the design phase to create accurate 3D models where we can see options, and even currently at the conceptual stages. So even when we are at the very early planning stages, we have tools like, for example, this one is Autodesk InfraWorks. We can easily simulate the new routes and get some kind of realistic visualization for our planned routes at very early stages without even detailing the railway. Real-time monitoring and decision making. Usually, we have the operational insights and maintenance alerts. BIM and GIS can provide help to the real-time operational insights, where GIS capture location-based data and BIM offer detailed understanding of the infrastructure conditions. So there are huge potential for this area. As I mentioned, BIM and GIS are already there. We have the models from design and construction. We can feed these through any platform. These platforms can be BIM platforms that we are used to use pre-handover, or other platforms that's dedicated for asset management, but take the models and link it inside these management platforms, or also have the GIS context within these platforms. So it can be either way. Compliance and reporting. We have the regulatory compliance, where BIM and GIS can assist in proving that we are complying with regulations. It can help in maintaining detailed record of infrastructure conditions. All of this can be maintained and reported. BIM and GIS are very powerful when it comes to reporting and documentation, so it can help in the compliance and reporting part. Okay, so as we understand where BIM and GIS can help in that, we can't use BIM and GIS for proper asset management without proper asset information requirements. So it's essential to have proper asset information requirements in place, where it dictates the requirements for the BIM and GIS deliverables that will be handed over at handover stage. And when we speak about asset information requirements, we should speak about ISO 19650 standards. And one of the important notes that we should make us think is when ISO 19650 chose a diagram to illustrate the federation strategy, where we are at design stage and we want to ensure that we have specific areas dedicated for specific systems. The example that they used were for railway project, and this is to understand the complexity of such projects. So it's just a note to understand that ISO 19650 consider this as one of the types of projects that can make use of information standards. I'm sure you are familiar with this diagram that comes from ISO 19650 Part 2. If you have some experience with ISO standards for BIM and information management, this diagram is representing the process during the delivery phase of asset. And usually, as per this diagram, we have this area B, which is a project starting or the delivery part of the project, which can cover the design and construction. And usually an owner or what we call the appointing party will come at this very early stage to define their requirements at an activity or part of the project called assessment and need. So this is the earliest activity where the information requirements are defined and um, cascaded to the supply chain. So this is a simple diagram that shows the delivery post handover. So usually, as per this diagram, the handover happened at the project closeout at this part. Usually, the information is defined, then the supply chain go and do their or deliver their models, their information, all as per the information requirement, and then we reach this project closeout at the end of delivery phase. But this is the simple one. We have another extended diagram from ISO 19650 part 3. And part 3 of ISO 19650 speaks about the operational phase of the asset, which is mainly focused on the asset management and define the asset information requirements. In this case, we need to understand that the management of asset information is more complex because there are multiple scenarios. And as per this diagram, usually the client will define the requirements at this stage, at the very early stage of their involvement in the asset management. So currently imagine that the owner of the asset brings an operator or a facility management organization to manage this asset. And then this entity will come to define their requirements. And then they will have some trigger events where they will be involved in this project. There will be multiple scenarios. The easiest one is where they are involved here in the middle one, where the delivery of the asset already happened. So the design and construction already ended, and then they handed over the data to either the operator or the owner, and then the owner handed it to the operator. So this is the simplest one. The data is already, or the information model is already created and accepted by the appointed party, and then it's handed over here to this stage 8. Another situation will be, or a great situation or an ideal situation where the asset operator or the facility management team are involved at the very early stage and they are involved before the creation of the data happens. And this is usually rare and ideal because then they will have all of their information captured by the design and construction teams, and that's where you will have clarity among the supply chain. So the contractor will know which data they need to provide, and then they will provide it in the format that the operator need, and will be a great scenario. However, there is another scenario where this asset operator joins the project while the delivery is ongoing. Somewhere here, for example, so maybe after the procurement of a contractor, or maybe within the procurement stage. So usually they will try to implement as much as they can from their information requirements, but usually this is not very ideal, but this is the most repeating situation in today's world. So regardless the situations that we'll have or the scenario that we will go through, usually here happens the asset information model aggregation. So in most of the projects, there will not be one scenario. There will be multiple contractors delivering multiple works, and some contractors will join at the very early stage, and they are working only based on best practices. But then you will have contractors delivering at the end of the project. Maybe at that time, the operator is there, the information requirements are there. So there will be multiple data with multiple structures, and then there will come the point where asset information is consolidated in a way that can be handed over in a proper way. So this stage is essential, and the most that we can to ensure that all data coming to this stage are at the same structure or at the intended use the best that we have our data handled. To achieve that, it's important to understand another concept, which is the level of information need. And we need to understand that not every information deliverable is the same. Before any request of data, we need to understand why we are submitting this data, when we will submit the data, who is submitting this data, and what will be submitted. And the most important, how this information will be submitted. And if we understand the concept of the level of information need, we need to understand that data at handover is and should be different from any data that's submitted at very earlier stages. So data that are submitted for construction will be for sure different from data that are submitted for asset management. That's why we usually have two types of models: project information models and asset information models. So imagine this orange part on the left-hand side as a project information model, and this green part is a asset information model. So usually during the design and construction, data will be submitted, include 3D models, schedules and cost models, warranties and guarantees, geospatial data, 2D drawings. So all of this data will be captured and submitted, but for the purpose of the delivery of the project. However, there will be other data that will be submitted for other purposes at the asset handover stage, which will be called the asset information model. This can include preventive maintenance regimes, upgrade and renewal requirements, shutdowns and outage strategies. So this, for sure, there will be overlaps. And as you can see here, most of the data from the project information management can go as part of the larger handover deliverable, but it needs to be understood that there are two types of data: project information model that contributes to the asset information model, and then the asset information model that supports the management activities. We need to understand that at some projects, the asset information model can be very simple model that have only critical information needed for the asset management, while in other projects, it can be very complex where the operator want to have a comprehensive digital twin that have everything within it. So we need the information requirement and the level of information need to define what kind of information will be delivered, so that our BIM and GIS deliverables can support the asset information management. And usually the asset information types are either data or geometric information or documentation. So when it comes to asset data, it can be classifications, attributes, serial numbers, locations. Geometrical data can be 3D, 2D, GIS, and documentation can be any kind of certificates, warranties, or manufacturer manuals. All of these need to be captured in a way and handed over as part of the asset information handover, so that this can help in the asset data management. Last slide as an example of some tools that provide this kind of asset information classification and then collection and validation. This is one tool that were recently acquired by Autodesk called Datum 360. And this tool have this capability of capturing, or let me start from the beginning. It allows owners and operators to define their asset information requirements and classification and level of information need, gather it in this system inside this Datum 360 in what's called CLS or class libraries, and then allow them to use the same tool for contractors, for example, and operators, or any kind of involved stakeholders to add their data, whether inside BIM models or whether inside any electronic data management system. And all of these data will be captured and validated against the information requirements. And this saves time and makes this Datum 360 as a connected data platform that capture the information and ensure the compliance of this information against the information requirements. So this is one example. There are other tools might be in the market in progress to have this link that allow the proper and efficient handover of digital data from the construction stage to the asset management stage through proper handover to ensure the data is captured as intended. I think this is all what I wanted to capture in today's session. And now I'll open the floor for the questions. And I
Perfect,
see that.
Mustafa. Thank you. Thank you so much. Let me
you.
get back my presentation here, just to
Sure.
put the QR code for our masters. I don't know if you are seeing my screen now or I see
A
yours.
moment. I think I still see my screen, but let me try and stop sharing. Yeah, now I see your screen.
Perfect. I saw, let's move on to the Q&A. Thank you so much. That was really insightful. Thank you.
You.
I saw some questions here and some comments also. I saw one comment at the beginning of your presentation that was really interesting. Sudeep comment that this person is involved in the redevelopment of railway stations in India, and BIM is a mandate in all these assignments. So I saw this
Okay.
comment and it was really interesting. And I saw another one here. Let me see. From Ahmed. Ahmed commented, thanks Mustafa for the insightful session. Having worked on Sydney Southwest project as part of the delivery team, I've experienced the challenges of coordinating between the project teams and the BIM GIS functions. From your perspective, what are some effective strategies to ensure smoother coordination, especially during the post-construction and handover stage, where data consistency and clarity become even more critical?
That's a complex question. So firstly, let me try to capture parts of it. So firstly, the challenges about coordinating between the project team and BIM and GIS functions. It comes back to the principles of, let's say, information management as per ISO 19650. There should be like roles and responsibilities clearly defined. Before ISO 19650 and maybe in PAS 1192, there was previously definitions for exact BIM roles and exact responsibilities for every roles, but we realized maybe this is not very practical. So then we moved to the shift into as per ISO 19650, the essential or the importance of having roles and responsibilities defined per project. So it should be the responsibility of the project team to assign these roles and responsibilities. So it doesn't matter whether you have a BIM manager or a BIM coordinator or a BIM specialist. It doesn't matter what's their job title, but what matters the most is assigning responsibilities against roles. And these responsibilities can be deliverables, which is one of the most common things, or maybe tasks, or maybe responsibilities for parts of the projects. So this is a common way for managing these. And also it's very important to understand that BIM and GIS are facilitating tools for other project roles. So at some projects, maybe a few years ago, I saw this kind of wrong expectations from BIM and GIS functions where they are expected to be very technically or have a strong technical background, but that's not essential. If someone is just having a BIM or GIS function, they should be the facilitators for other functions like design and construction. The second part of the question is related to some effective strategies to ensure smoother coordination. This is what I can suggest here is trying to use the newest tools for online coordination or cloud coordination rather than the usual emails and even using Teams for this kind of stuff. There are currently platforms. One of it is Autodesk Construction Cloud model coordination platform where, and even is Autodesk Construction Cloud build where issues are captured directly on a cloud that's connected with other project information like models or data, and directly the issues can be assigned to project team members and communication can happen immediately. Photos can be captured to help this. So my generic recommendation here is to ensure you have the digital tools that can support this smoother coordination where the issues can be solved immediately together with the information that help in resolving these issues. Handover
Perfect.
stages, I think I covered when I spoke about Datum 360 and similar products that can help the post-construction and the handover stage. It's a platform that can capture the requirements and ensure that all information is aligned with the requirements.
Perfect, Mustafa. Sorry, one moment.
Sure.
I saw another question here. Clients in India are not able to create a proper EIR.
I think I can see the question here also. Yeah, clients in India are not able to create proper AIR at time of tender. Would you have some advice to such clients, such as consultants? We could assist them. Yeah, usually I would say as per ISO again here, the task of creating the EIR or AIR is the responsibility of the appointing parties. However, again, as per ISO, whenever this appointing party don't have the capability, the internal capabilities within them, they are free to assign this responsibility to another stakeholder, whether it's one of their current consultants or to a third party that can help them into creating these information requirements, whether it's for exchange or for asset information requirements. And if you recall the figure that I showed, where usually there can be several cases where the information requirements is created or used in the project from the start or at the end or at the middle. These aspects need to be considered when we are creating such documentation. So I would advise clients to ensure that they have proper information requirements in place. It's essential and it's becoming a must, because if you don't have proper information requirements as early as possible, you have BIM deliverables or digital deliverables, you will end up with piles of information at handover stage that's not structured and that's not answering your needs. It will be just tons of digital assets that you can't use and you can't find information within it. The EIR and the AIR is the guarantee that you can get this information in a proper way.
Perfect. Thank you so much, Mustafa, for saving me
No,
in this moment here.
no,
And
we are fine now.
to finish, do you want to leave a message to our audience, to everyone that we connected and everyone that will receive the recording?
Yeah, for sure. I want to stress on two things. Firstly, BIM and GIS is two powerful tools that can help in many aspects, and there are huge investments that are done by clients and by organizations, consultants, and contractors to develop these capabilities within their teams. So it's important to try and make use of these resources as much as possible for the life cycle of our projects, essentially for the asset asset management part, which is the longest part of our projects. And yeah, secondly, on personal level, for professionals attending this, please understand that this world of digital engineering or digital construction or digital asset management is evolving all the time. So always keep open to learning more, to keep yourself updated, to understand new techniques, and be open to this developing world. And I'm sure that today, what we are learning today, I'm sure it will be very different after 10 years, but the most essential part is that you keep learning. And yeah, that's it.
That's perfect. So a big thank you to Professor
Thank you.
Mostafa for sharing your insights with us today. And of course, thank you all. Thank you everyone for joining us. We hope to see you at your next event. Take care and goodbye for now. Thank you. Thank you so much, Mostafa.
Thank you. Thank you.
Thank you. Hope to see you in another events. Bye bye.
Bye bye.